we know. Then the second one, static methods. One, static initializers or blocks. Same thing for non-static members. Really. So non-static members are non-static members means the members which are declared inside the class block and not prefixed with static keyword. So examples of or types of non-static members: non-static variable. Then the second one, non-static method. The third one, non-static block. Advantage of a constructor. What is advantage? To load non-static members into object. To load static members into the object, it is the advantage of using the constructor. Take advantage of constructor. I will take down of parameterized constructor. Okay, what is the advantage of parameterized constructor? To initialize non-static variables during object creation time. During the object creation time, it is the advantage of the parameterized constructor. Then after constructors, we need to know the difference between this call statement and super call main. First, we will discuss about this call statement. So, can you tell me what is the use of this call statement? Anyone? What is the use of this call statement? Hmm. I'm audible, right? To call the constructor of same class. To call the constructor of same class. Then Can I write or can I add this call statement in all the constructors? Yeah, good. So this call statement can be added only in n minus 1 constructor. So n means n means total number of constructors. N means total number of constructors. Then any other differences about this call statement? I think it's enough for the this call statement. Then what is the use of super call statement? To call the parent class constructor. To call the parent class constructor. Then we can add super call statement inside all the constructor. We can add super call statement inside all the constructor. And if programmer fails to add this call statement, compiler will implicitly add the super call statement. Yeah, but it should be the first statement. It should be the first statement inside the constructor. It should be the first statement inside the constructor. So same thing for this call statement also. It should be the first statement inside the constructor. Then in the like can we add both this call statement and super call statement inside the single constructor? Both this call statement and super call statement. No. The answer is no. We cannot add both this call and super call inside the single constructor. Inside the single constructor. I think it's enough about the constructors. Now we will start with the OOPS concept, that is encapsulation. So I think everyone, you are confident, right, in the encapsulation? Is it required to discuss now? Tell me, let me know. If you want to discuss, we will discuss. Or else we will move to the inheritance. Shall we move to the inheritance now? Okay. So inheritance. So in the inheritance, the process of acquiring all the properties from one class to another class. You call it as inheritance. So here to achieve inheritance, what we have to do if I want to achieve the inheritance? Only extends keyword. Only extends keyword. Is there any other keyword for the inheritance? Implement also, right? Yeah. So extends and implements keyword. Extends implements. So extends means what? So extends means it is used to achieve inheritance between two classes or two interfaces. Yes or no? For example, see here, now I need to achieve an inheritance between two class B extends of A, then interface interface A, interface B, interface B. Should I use implement C now? Implements of A. Is it correct? Implicit word here? No. We have to use the extends keyword. When we have to use the implements keyword, then when we have to use the implements keyword, we need to use implements to achieve interface to the class or class to the interface. It is correct. We inherit interface to class or class to interface. Interface to class. Telling so what you are telling class A, then interface B implements A. It's wrong, right? It is correct. First one or second one? It is first one. It is second one. It is correct. First one or second one? So first one is correct. Second one is wrong. First one is correct. Second one is wrong. We cannot inherit class to interface. Then afterwards, types of inheritance. So I think everyone you will be perfect. Types of inheritance. Single level, yeah. Think no need of discussing these things. Single level, multi-level. Yeah, Pradeep will discuss that. Aggregation and composition. Multiple, hierarchical, then hybrid. So these are the five types of inheritance. I think you know all these things. Then payment problem. Payment problem. It is also right. Payment problem. Ambiguity or confusion faced by the compiler. The compiler during multiple inheritance. Should we discuss payment problem? Is it required? Not required, right? Yeah, and Pradeep asked, yeah, and Pradeep asked, that is, what do you like? What is the meaning of Abhishek? Have written right here. See, ambiguity or confusion faced by the class A and class B are the parent classes. Class C is the child class. So now from a class C constructor, you are trying to call the parent class constructor. So super call statement, super call statement. Yeah, that program will see in the interface. So now compiler will be in the confusion to call class A constructor or class B constructor. So it is the diamond problem faced by the compiler in Java. Then yeah, that aggregation and composition. Nowadays they're asking now about the aggregation and composition. So we know the in Java we have a relationship concept. Relationship means what? The connection or relation between two objects, or we call it as the dependency. The connection or relation is enough between the two objects, not go for dependency. So here we have two types, that is as a relationship, as a relationship, and is a relationship. So is a relationship we are perfect, that is inheritance, right? Is relationship means what? Inheritance. So how many types of easier relationship are there? How many types of easier relationship are there? Five types we have discussed before. Then what are the types of as a relationship? Or else first we will discuss what is as a relationship. So as a relationship means the dependency between two objects. The dependency between two objects, we call it as a relationship. The dependency between two objects, we call it as a relationship. Yeah, same thing. If one object is depend on another object, so dependency word is important. Yeah, dependency word is important. So now in as a relationship, we have two types. First one, aggregation, and the second one, composition. It's or no? Aggregation and composition. So aggregation means what? Aggregation means what? What do you mean by aggregation? Car and engine. Car and engine. Yeah, tell me, like, give me some sentence or definition about the aggregation concept. One object is depend on another object, but not completely. One object can hold the properties of other object. Good. One object can exist without other object. Good. Yeah, like music system in car. Good, Shawaj. So one object can exist without the other object. Yeah, for example, as you said, Shawaj, music system and car. Music system and car. Yeah, good. Mobile and SIM. Yeah. Okay. Pen and cap. So these are the examples of the aggregation. See, in the definition only we can understand. One object can exist without the other object, or else without depending on other object also you can consider, without depending on other object. For example, for music system and the car, we have aggregation. For driving a car, whether music system is mandatory. Without music system, can we drive the car? Sir, no. Drive the car without music system. So here, call object is not depending upon the music system and mobile and SIM. So here we can use the mobile without the SIM also, no problem. And pen and cap, we can use the pen. We can write anything without the cap. So pen and cap are the, like, pen and cap, music system and car, mobile and SIM are the examples of aggregation. Then composition. The composition means one object cannot exist. Here cannot exist depending on or else without other object. Without other objects. For example, same examples we will take. Car and wheel. Above examples. Above examples only we will take. Car and wheel. To drive a car, wheel is required. Without wheel, car will not run. Then mobile and battery. Above examples only we are considering mobile and battery. So for using mobile, you can use the mobile without SIM, but battery is required. Then pen and cap. Yeah, Emangi said pen and ink. That is pen and refill or ink. Okay, I'll consider ink only. Pen and ink. Yeah, human and not good. So that's all about the as a relationship. And how can we achieve as a relationship? How can we achieve aggregation? Yeah, how can we achieve the aggregation? You tell me. Lazy instantiation. Yeah, good. We can achieve aggregation with the help of lazy instantiation. Then we can achieve composition with the help of early instantiation. We can achieve composition with the help of early instantiation. Yeah, that's all about the as a relationship, aggregation and composition. So easy relationship we have discussed in the inheritance. Yeah, both are same. Easy relationship and inheritance. So now we will discuss about polymorphism. So polymorphism, one object exhibiting one object exhibiting many forms or different forms. We call it as polymorphism. So here we have two types of polymorphism. First one, compile time polymorphism, and the second one, runtime polymorphism. Compile time polymorphism and runtime polymorphism. So can you tell me how can we achieve compile time polymorphism? What are the types of compile time polymorphism? Method overloading, constructor overloading, then method shadowing, I'm taking it. Nikita, here compile time polymorphism. Not we are still we did not go to exception. Do not get confused. Yeah, last one that is variable shadowing is also there. Variable shadowing. So these are the ways of achieving the compile time polymorphism. So runtime polymorphism we have only two types. Now, method overriding, and the second one derived typecasting. Method overriding and derived typecasting. So in this, like I think you'll be perfect in method overloading and constructor overloading. It's or no? Method shadowing. Tell me which topic I need to discuss. Derived typecasting and non-primitive casting. I mean, both are same. Derived typecasting and non-primitive typecasting both are same. So in this, which one we have to discuss? Method shadowing and variable shadowing. Okay, so method shadowing. Oh no no. One thing we will do. First, we will go to runtime polymorphism. That is method overriding and derived typecasting. We will discuss, and then we will come back to method shadowing and variable shadowing. It will be easy. During compile time binding. During runtime binding. So now tell me something about method overriding. The process of giving new implementation for parent class method in child class. We call it as method overriding. So it is for only non-static methods. Method overriding is only for non-static methods. Then rules of method overriding. So inheritance should be there. Inheritance is mandatory. Then axis modifier should be same, or axis modifier should be same axis modifier should be same or higher visibility. Deepali Borkar, you are telling all the points of method overloading. See, parameter must be different and method overriding perform within the class. These are all for method overloading. Here we are discussing about method overriding. Check it in your notes. Then return type can be same or different, or else yeah, can be same. It's enough. Fourth one, method signature. That is arguments. Arguments should be same. So these are the rules of method overriding. Then afterwards, we'll write one example. So class A, then class B. First we discuss derived typecasting, that is non-primitive typecasting. Then we'll write one example for both method overriding and non-primitive typecasting. So in the derived typecasting, upcasting and downcasting. We have only two types: upcasting and downcasting. What do you mean by upcasting? Upcasting means what? Child to parent. Okay, what? Okay, child to parent what? Converting the address, yeah. Not transferring, converting. Yeah, but transferring is also good. Chawaj. Transferring is also good, but it is not up to the mark. The word transfer is not up to the mark. So you can tell converting. Yeah, good. From child class type into parent class type. Converting the address from child class type into parent class type. Or else converting child class reference type into parent class type. Yeah, everything is same. We call it as upcasting. Then what is the advantage of upcasting? What is the advantage we can achieve? We can achieve generalization. No, we can achieve generalization. Then disadvantage. Disadvantage. Yeah, generalized container both are disadvantage of derived typecasting. Yeah, we can't access the members of child class. We can't access the members of child class. It's all about derived typecasting. For derived, sorry, not derived typecasting, upcasting. So for upcasting, we call it as implicit typecasting also. Upcasting, implicit typecasting also. Then for the downcasting, we call it as explicit typecasting. That is converting the address from parent class type into child class type. Then what is the advantage of downcasting? We can overcome the disadvantage. Yes or no? Advantage. Showers. We can overcome the disadvantage of upcasting. can overcome the disadvantage of upcasting. Then disadvantage, disadvantage. So disadvantage is what? Sometimes this class cast exception. Disadvantage is class cast exception. But here, when it comes to downcasting, we have to use typecast operator. We have to use the typecast operator for downcasting. Yeah, typecast operator is mandatory. Now we can write. Now we will write the program for that. We will see one by one. Let me know. So class of A, class B extends A. So public void add no argument. A same method, same arguments in child class also. It is printing B. So now it is an example of method overriding. Yes or no? Non-static method in both parent class and child class. Same arguments, same thing. Now can I give here it as protected instead of public? Can I give here as protected? Ah, check. Here we have written one point right about the method overriding. Axis modifier should be same or higher visibility. No. Listen here, Shavaz. Axis modifier should be same or higher visibility. So can you tell me the axis modifier in the higher visibility format? What is the lowest one? Lowest visibility when it comes to axis modifier. Which is the lowest visibility? Private. Yeah, private. Shweta, it is the topmost. What you have said, right? Public is the topmost. It is the highest. So first private. Then after private, what is the thing? Default. Default. Protected. At last we have public. Private, default, protected, then public. Good. See now. Now can I use here private? Now is it allowed? In the class A private, in the class B protected. So higher visibility only, right? Yeah, higher visibility. In the child class, watch, you need to maintain the axis modifier which has higher visibility comparing to the parent class axis modifier. So private is the lowest visibility. So comparing to private, protected is the highest visibility, right? Comparing to private, protected is the highest visibility. So here, if the axis modifier in the parent class is private, I can use all four axis modifiers: private, default, protected, public. And if I make it as protected axis modifier here in the parent class, so which axis modifiers can I use here? How many axis modifiers can I use? Only one. Only one or two. Can I use protected? Again, protected I can use. I can use protected or public. Yeah, only public and protected. Only two axis modifiers. Protected also we can use. And more than protected, we have public. We can use that also. Then if I make it as public here, how many axis modifiers can I use here? Only public. Only public. Here I cannot use protected, default or private access modifiers. Understood? While overriding, access modifiers can be same or it should be of higher visibility. Yeah, guys, 1 minute. Yeah, sorry, we'll continue now. So here in the same program, I'll create one main method. Yeah, sorry. So string array arguments. Now what I'll do, I'll try to write an upcasting instruction. So a of a1 equals new b no argument. So it is an upcasting instruction. But we know that once we upcast the address from child class type into parent class type, we cannot access the members of child class. But If I call a1 dot m1 no argument, that is add no argument, what will be the output? If I call a1 dot add no argument, what will be the output? From A or from B? Child class output from B. Yeah, good. Here the output will be from B, not from A, because overriding will happen. Method overriding will happen. The address will be overridden. The address will be overridden. You will not get the thing. But see now, I'll create one variable int a equals 10 and int b equals 20. See now, but here if I call a1 dot a, or else wait, what I'll do, I'll make it as a1 dot like both. Here also class C also variable a and class B also variable a. So a1 dot a, what will be the output? Here 10 or 20. A1 dot a 10. Here the output will be 10, not 20. How can it be 10, 20? Here the output will be 10. Here there is no method over. Method overriding is for methods or variables. Overriding is for methods or variables. Methods, yes or no? Yeah. In the variable, there is no changes. Variable overriding is not there. No, no, variable overriding is not there. Variable overriding is not there. Variable shadowing is there. Yeah, good Sagar. Variable shadowing is there. Yeah. Now, if I want to access the child class member, what I have to do now? If I want to access the child class member, I need to get the output as 20. What I have to do? Should I create one more object? Or else can I write the downcasting instruction as Abhishek said? Directly I can write the downcasting instruction. Yeah, so I'll take it now. B of A2 equals B of A1. Now with the help of A2 dot, with the help of A2, I can access the members of the child. That is, it will become 20. Now the output will be 20. So here method shadowing and method overriding. So method overriding is for the non-static variables in both parent class and child class. Non-static way, no sorry, non-static method should be there. Non-static method. But when it comes to method shadowing, in both parent class and child class, same method and same signature, but if the method is static. But if the method is static, we call it as method shadowing. You see, no? Class E, I'll take public void demo no argument. Then class B extends of E, that is public void demo no argument. See now, both are non-static methods, but if I add static keyword, it becomes a method shadowing. It becomes method shadowing. That's all. That is the difference between method shadowing and method overriding. Method overriding is for non-static methods and method shadowing is for static methods. And variable shadowing, right? See now, that's all. In both parent class and child class, same variable, we call it as variable shadowing. But variable shadowing is for both static and non-static. But when it comes to grooming time, from 2 to 4 it is. Just it is from 2 to 4. But method shadowing is for static only. So I hope polymorphism is clear. Any doubt in the polymorphism concept, let me know. Shall we move to the abstraction now? Java class from 1 to 3. Yeah. You are from which batch? WCCA 12. Rajashri. Okay. WCC 7 class at what time, Shawaz? 3:30 or 4? 3:30. Okay. Like we will end at 3:30. I will complete abstraction. From tomorrow, like tomorrow, again we will take one more session. There we will see object class, exceptions, and collection framework. Okay. See now, abstract. Okay, we'll let you know. First, we'll let you know about that. Abstraction means hiding the implementation, hiding the implementation, and providing only the important features. We call it as abstraction. So here we have abstract class. Abstract class. Can you tell me what are the members we can declare inside abstract class? What are all the members we can declare inside the abstract class? Only abstract and concrete methods. Final and non-final variables. Okay, good. So static and non-static variable I can declare. Like we can declare then static methods we can declare. Then abstract method and concrete methods we can declare. Then constructors are allowed. Static and non-static blocks are allowed. Static and non-static blocks are allowed. So these are all the members we can declare inside the abstract class. But there are some other characteristics also. We cannot achieve like how not how why constructors are allowed, right? Okay, we'll discuss that. We cannot achieve 100% abstraction. We cannot 100% achieve, sorry, we cannot achieve 100% abstraction in abstract class. This is a major drawback of the abstract class. Then afterwards, we know that we cannot create an object. Why we cannot create an object for abstract class? What is the reason behind that? What is the reason behind not creating an object for abstract class? What is the reason behind that? Let me know. No implements. Hey, no, 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 no. Because no implementation. Because concrete methods. No, I mean constructor is not present. Constructor is present. Sagar. Constructor is constructors are present. Constructors are allowed. See, abstract class. When you will make the class as a abstract class, can you tell me? When you will make the class as a abstract class? If the class contains at least one abstract method, at that time you will make the class as a abstract class. Yes or no? See, no. Class of A abstract public void m1 no argument. Now is it mandatory to make the class as a abstract class? Tell me yes or no. Now is it mandatory or not to make the class as a abstract? Yeah. So abstract. Consider now. Consider now. Consider now we can create an object for the abstract class like this. A of A1 equals new A no argument. Then A1 dot M1 no argument. A1 dot M1 no argument. You see now, I'll add one variable int A equals 10. Now if I call A1 dot A, if I call A1 dot A, will it give the output? If I call A1 dot A, will it give the output? 10. But wait, listen here. You know that we cannot create an object. But as of now, try to create an object and call the members. Think now. If I call a1 dot m1 no argument, what will be the output? Will it give any output? Will it give any output if we call also? No, right? So due to this, they made because it is incomplete. Or else we can tell we cannot create an object because abstract class is incomplete. Okay, guys, there is one meeting. I'll attend it and I'll come back. Give me 5 minutes. There is one meeting. I'll come back. Okay.